Hello class, welcome to Unit 10, Video 3. Today we're going to be looking at properties of logarithms. Your learning targets for today are that you can simplify and evaluate expressions using properties of logarithms. You're also going to use those properties to solve logarithmic equations. Okay, so we need to know those properties, but before we do that, let's just think about the properties of exponents. Okay, since logarithms are exponents, the properties of logarithms can be derived from the properties of exponents. Okay, so thinking back to our product of powers property. So when we multiply exponents, what do we do with them? We would add them. So when we're talking about exponents, multiplying and adding are kind of a pair, which seems weird, but it's not. Also, quotient of powers property is 3 to the 4th over 3 to the 2nd. Well, when we divided, remember we subtracted. So this would give us 3 to the 2nd. So multiplying and adding go together, and subtracting and division go together. Okay, and since logs are exponents, we have similar properties of logs. Here's the first property. Product property of logarithms. The logarithm of a product, which means multiplying, is the sum of the logarithms of its factors. So if I have two numbers being multiplied, now I can go ahead and break it apart with addition. Okay, just like before, here we're multiplying, so we could add the exponents. So if I have log base 3 of 2 times 4, I can rewrite this as log base 3 of 2 plus log base 3 of 4. Okay, so there is our product property of logarithms. So multiplication, I can rewrite it with addition. Just notice there's one log with the multiplication, but when I break it apart, there's 2. Okay, and you can also go backwards. If I have addition, I can rewrite it with multiplication, but there's only going to be one log. So example 1 says use log base 4 of 2, which is approximately 0.5, and log base 4 of 3, which is approximately 0.79248, to approximate the value of log base 4 of 6. So the first thing that I would do is just break this apart. 6 is really 2 times 3. So we have log base 4 of 6 is really equal to log base 4 of 2 times 3. And using our properties, I have multiplication, so I can rewrite it with addition. So it's really log base 4 of 2 plus log base 4 of 3. So here, this would give me 0.5, and this, they tell me, is 0.79248. Okay, so all I have to do to get my final answer is to add them together. So on my calculator, I would take 0.5 plus 0.79248, and my answer is 1.29248. Okay, so if you have to do this on your quiz, make sure you use the numbers provided, because you can do this on your calculator. However, it will not give you the exact same answer that I have here. Okay, so there is example 1. Example 2, a little bit different. It says use the log base 2 of 3, which is approximately 1.5850, to approximate log base 2 of 48. So let's just go ahead and break 48 down. 48, 2 times 24, and let's break it all the way down. This is 2 times 12, 2 times 6, and lastly 2 times 3. Okay, which means it is log base 2 of 48 will be equal to log base 2 of 2 times 2 times 2 times 2 times 3. All right. So from here then, I can go ahead and write this as multiple additions. So I will have log base 2 of 2 plus 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 log base 2 of 3. Okay, so it got a little bit crowded. Okay, and then I look, what did they give me for an answer? They only told me log base 2 of 3. All right, but there is another property. Okay, and let's maybe write a little note. Log base 2 of 2. Okay, 2 is really to the first power. Okay, I can write anything to the first power. But if these two are exactly the same, so must be the same, they cancel each other out. They really have a value of 1. So I am left with my exponent, which is 1. Okay, so that is what this is equal to. So I can just go ahead, really, this is equal to 1 plus 1 plus 1 plus 1 plus log base 2 of 3. Log base 2 of 3, which we had is 1.5850. 1, 2, 3, 4, 5.5850. That would be my answer for example 2. Okay. I want to approach this one other way though, because there is a little bit quicker way to write this. I can really write log base 2 of 48 is equal to log base 2 of 2 to the, there's 4 2's here, 2 to the 4th times 3, which would break down into log base 2 of 2 to the 4th plus log base 2 of 3. When I do that, notice my base and the base of my log are the same, so these would cancel, and all I'm left with is my exponent. So it's 4 plus log base 2 of 3 is that 1.5850, which gives us an answer of 5.5850. Okay, so either way is right to think about it. This one is a little bit less work, a little less writing, but this is maybe an easier way for you to think about it. Up to you, they will both work. Okay. Example 3 then. Okay, we need to solve this logarithmic equation. Okay, it says logs on one side of an equation. You combine the separate logs into one, okay? And then you put it into exponential form and solve for x. So what we're doing now is we have something with addition here, and I'm going to rewrite it with multiplication. That's the first thing you need to do. In order to solve, you have to make it one log on each side. Okay, so I would have log base 4 of x times x minus 6 equals 2. Okay, now we have to go back to our exponential form. Remember, it's 4 to the second is equal what's left in here. So 4 squared is equal to x times x minus 6. Let's simplify. 4 squared is 16. If I distribute, I get x squared minus 6x. Now we have a quadratic. Remember, to solve a quadratic, you have to have 0 on one side, so I'd subtract the 16 over to the other side. And lastly, we need to factor. Well, multiplies to negative 16, but adds to negative 6. Negative 8 times a positive 2. Then I would solve it. So I would have x minus 8 equals 0, so x is equal to 8. And x plus 2 is equal to 0, so x is equal to negative 2. Remember, you can't take log of a negative, so if I plug it back in, do I still have a negative? Yes, so this one's not an answer, but x equals 8 is my solution. Okay. Example 4 is very similar to example 3, so I would recommend pausing the video and you try example 4 on your own. Okay, hopefully you pause the video and try this problem on your own. First step for it is to write the addition as one log. So I would have log base 8 of x times x minus 12 equals 2. Now I put it in exponential form, so I take, it's going to be 8 to the second equals x times x minus 12. So I would have 64 equals x squared minus 12x. And if I if I subtract the 64, I have x squared minus 12x minus 64. Then I would factor what multiplies to negative 64, but adds to negative 12. This one takes a little bit of thinking. 1 times 64 isn't going to work. Then it'd be 2 times 32. That doesn't work. 64 is not evenly divisible by 3. How about by 4? 64 divided by 4, I think it's 16. 64 divided by 4. It is 16, so we'd have 4 times 16. Would that work? Yeah, it would. So I'm going to have 4 and 16. To add to negative 12, this would be negative, this would be positive. Now we go ahead and set each part equal to 0. All right, so then I would check. If I plug it in, I would get -4. So that doesn't work, but this one will, okay, because it's positive 16. All right, that is it for example 4. If you have any questions, please write them down. Otherwise, we're going to go ahead and move on to our quotient property of logarithms. Okay, so quotient means division. So just remember with our exponents, when we divide with division, we actually subtract the exponents. Same thing with logarithms. All right, so when we have division, we subtract. So we are left with, why did I rewrite that? So it'd be 3 to the 4 minus 2, which is 3 squared. Okay, so same idea. So now our rule with logs is if you are dividing, you can rewrite it with subtraction. So quotient, remember, means division. So if you're dividing, that means quotient. Then you can rewrite it with subtraction. So for our example, if we have log base 3 of 4, it'd be, 4 over 2, it'd be log base 3 of 4 minus log base 3 of 2. Okay, and that would be how we would rewrite that. Let's go ahead and look at example 5. Okay, it's very similar to our example 1, except for now we have log base 3 of 5 and log base 3 of 20, and we want to approximate the value of log base 3 of 4. Okay, big hint is the numbers they give us. Okay, we have 5 and 20. With those two, is there any way I can get to 4? 20 divided by 5 will give me 4. So I'm going to rewrite this as log base 3 of 4 equals log base 3 of 20 divided by 5, because 20 divided by 5 is 4. Now I can break it apart with subtraction, because it is division. Okay, and now I would write in my numbers. Log base 3 of 20 is 2.7268 minus log base 3 of 5, 1.4650. Make sure you type in those whole numbers into your calculator, and if you do, you will get 1.2618. And make sure you list all the decimals that your calculator shows for problems like these. Okay, that is our quotient property of logarithms. The next one we're going to do is power of powers. Okay, so this one we would have 3 to the 5th to the 2nd. Remember, you multiply exponents. So this would give us 3 to the 15th. All right, so now when we look at our logs, what this allows us to do is if we have a power property of logs is if I have a power, I can bring it down in front and make it multiplication. So p times log of b to the m. Okay, so in this case, I can bring the 2 down in front, so it becomes 2 times log base 3 of 5. Logs are extremely helpful for the fact that you can take the exponent and put it down in front. Or vice versa. If I have 3 times log of 2 to the 5th, I can go ahead and take this 3 and put it back as an exponent. And so it'd be log base 2 of 5 to the 3rd. Goes back and forth. You can bring the exponent down in front, or you can put the exponent back where it came from. Okay, so let's use that idea for this one. This one says, use the value of log base 4 of 6 to approximate the value of log base 4 of 36. So what I would do is, I know I have 6, so how can I rewrite 36? Well, it's really 6 times 6. So I'm going to rewrite it as log base 4 of 36 is equal to log base 4 of 6 times 6. That's really just 6 squared. Now I can take my power and bring it down in front. So I would have 2 log base 4 of 6. I know what log base 4 of 6 is, so it's 2 times 1.2925. And when I multiply those, I would get 2.585. Okay, that is example 6. Example 7, okay, we're going to use all of our properties as 1 now. So we want to get the logs to have only 1 log on each side before we can do anything. Okay, so for 7, I would notice there's a number in front, so I can use my power property to put that 3 back as an exponent. So I would have log base 5 of x to the 3rd minus log base 5 of 4 equals log base 5 of 16. Okay, I said the goal is to get all the logs to have only one log on each side. So on the left-hand side, it is subtraction, so I'm going to rewrite it with division. Notice only one log. Log base 5 of x to the third over 4 is equal to log base 5 of 16. Okay, now this one is nice. Notice how they both have log of 5. So that means what's left in the inside, they have to be equal to each other. So I can just say x to the third over 4 equals 16. To solve this, I would times both sides by 4. So x to the third is equal to 16 times 4, which is 64. Silly me, we actually looked that up before. And then cubed root of x on both sides. So x is equal to the cubed root of 64. So what number 4 times? Well, maybe you don't remember. So you would go math, and then it's the cubed root's number 4 of 64, and it should give us an answer of 4, which it is. 4 times 4 times 4 gives us 64. So x is equal to 4. All right. Then I would just check 4 is positive, so if I plug it in, it will be fine. Good. Moving on to example 8. Okay. Once again, if you want, this is very similar to our last problem, so I would recommend you pausing the video and trying it on your own. Okay, so first thing is to get all of our logs as 1. But before I do that, I got to put my exponents back. So I have log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Now it's subtraction, so I'm going to rewrite it as 1 log with division. I can take these two numbers and set them equal to each other because they both have the log base 2. So x to the 4th over 5 equals 125. Times both sides by 5. I have x to the 4th is equal to 625. Now this one I would take the 4th root on both sides to solve for x. So x will equal the 4th root of 625. So on your calculator you would type 4, then math, and then the x root, so number 5. You can either arrow down or hit the number 5. Of 625 will give us an answer of 5. So x is equal 5, and it's positive, so it should work out perfectly fine as an answer. All right, last one on this note sheet, number 9. Okay. First step, take it and put the exponents back. So I'm going to put this exponent back. So I would have log base 7 of x squared equals, and now here, I'm going to write it as 1 right away. It's addition, so I would rewrite it with multiplication, so it's 27 times 3. So I have log base 7 of x squared is equal to log base 7 of 27 times 3 is 81. They are both log base 7, so I can ignore those and just take what's on the inside and set them equal to each other. And then I would take the square root on both sides. So I would have x is equal to plus or minus the square root of 81. So x is equal to positive or negative 9. However, could I have negative 9? In this case, I could not. So we would have negative 9 in there. So it would just be 9. Okay. All right. That is it for Unit 10, Video 3. If you have any questions, please let me know. Otherwise, have a great day, and I'll talk to you later.